Hello, my name is Steve Party. I'm a backend engineer at GitLab and I work on the GitLab Runner project. I wanted to give a small update on the work we have been doing on the Docker machine replacement. And what we have been doing so far is working on a load testing tool. Now, before we go into why what it's doing, I'd like to understand why we want to have a load testing tool. So the main reason is to validate the autoscaling solutions that we're going to provide, right? We want to check if it autoscales as we expect and if it autoscales ideally better than what we have right now. And this is going to provide a consistent way to test it. So every solution we test it in the same scenario. So you can say, okay, this is better for scenario X and so on and so forth. And we'll also take this into consideration from a performance perspective and even from a cost perspective. A GitLab Runner cluster might perform really well, but it can cost a lot of money. And then we'll be able to provide some metrics to our customers as well by basically saying, hey, if you configure your GitLab Runner cluster like this with autoscaling, it can run 10,000 concurrent jobs, given that the jobs are running these type of scripts. So I'd like to introduce a project called GitLab Runner Stress. This is a group project, so it has multiple projects inside of it, and we'll go through each project and the role it plays in one by one. And the main project is the Trigger project. The Trigger project is just a collection of GitLab CI/YAML files that is just triggering multiple applications. So here we're triggering the load on our GitLab Runner cluster. And it's going to trigger a Go application, compiling the Linux kernel, and the Ruby application as well, which has some Node.js inside of it. And it can also trigger benchmarks. So we want to have kind of both loading test the cluster from a load perspective and also from a performance perspective. So we'll benchmark some CPU, IO, memory, and even on a network level, since the network matters when we want to upload artifacts and do git cloning and so on. The application projects are for now 3. We can definitely add more, but I wanted to pick some more realistic applications. So the GitLab application itself, which is a Ruby application and Node.js. So it's a one big monolith application, which gives us a good understanding of like how monoliths will perform. A Go application, which is GitLab Runner. Both GitLab and GitLab Runner are running a frozen fork, and meaning that we forked those projects and we will not keep updating them. The reason for this is so we have, again, a consistent base. So we don't end up seeing like any performance improvements or regressions if we just update these forks. And then a Linux kernel compilation, because it's a good chunky C application that is compiled, and that will stress test the CPU a bit. And these are all using multiple GitLab features, right? Like services and so on. So we can also test like how well it performs on spinning up containers, for example. And they're fairly long pipelines as well. So we can also check like, okay, our auto-scaling algorithm bursts really well, but then it falls down after 20 minutes of running a lot of jobs. The last project we have is GitLab Runner Stress itself. It's a simple CLI application. It will be used to trigger multiple pipelines from the Trigger project. And this is mostly just a helper CLI, just so we don't have to click around in the GitLab UI every time. So a little demo of the GitLab Runner Stress. So we'll start with running benchmarks. So if we go to my terminal and just trigger the benchmarks, give me a second. And if here we're just saying, hey, run the benchmarks on the GitLab.com instance. And it gave us a link of the project. And if we go onto it, we can see the benchmarks pipeline is running. After that, we can also use this tool to run the load. And this one, instead of running the benchmark command, we'll run the trigger command. So if we just go here and type trigger, we can also specify the count. So for example, let's say we want to trigger 20 pipelines, 100 pipelines, and so on and so forth. I'm just going to put it onto 2 for now. And we can see it will trigger true pipelines for us by running the applications. Let's see if it runs all of them. You can see it started the Linux kernel, the GitLab Runner, and it's going to start the Ruby application soon. Let's wait a while, and there we go. We can see the GitLab pipeline being created as well. So what are the next steps after this? We can keep iterating on the GitLab Runner stress project. As you might seen, we're using the GitLab.com instance to trigger these projects, which is not ideal. And the reason for this is for multiple reasons, right? One, we're just creating a bunch of load on the production GitLab.com instance, which is not needed. And there are also some application limits in the sense that if we create a bunch of pipelines, those pipelines are going to be considered a failure because we're creating too many applications, and that is abusive behavior. So we want to create an export import command. In the sense, you have your own GitLab instance that we use just for testing with no application limits. It's not affecting GitLab.com production systems and so on and so forth. So it will be an easy way to export the group and import it, and then add tooling around pipeline timing. And it sounds like, let's get, okay, this pipeline took 30 minutes instead of 25 minutes, and so on and so forth, instead of just clicking around the GitLab UI. And this gives us an easy way to get timings, basically. That's it for now. Thank you so much for taking the time to watch this. Feel free to ping me on the Epic or any issue that you see about the autoscaling. My username can be found at SteveAWZ. And thank you so much.